Okay, Assalamualaikum and good afternoon. Okay, so we shall start our class. Oh, my bad. Sekejap ya. Okay. Okay. So before we go to the exercise, as last week, as our class last week, I'm going to summarize, okay, a few things, okay, regarding the subtopic for this week. Okay, but I want to start with the histogram here. It should be the last week punya topic, but because of it is in your assignment, so that's why I want to discuss that lah. Okay. So histogram is one of the graphical that we can use for the quantitative data. Okay, so in your assignment, okay, I don't remember which question, but you need to construct the histogram for all the data set that you have. Okay, so as I explained, you will have 4 data set. Okay, if your group, you divide your data, so you need to divide your data by the group. Okay, so let's say that the group is a gender, then you will have male, first group, and second group is a female, for example. Okay, so under each group, male and female, you will have 2 sets of data lah. Okay, so that 2 set of data, one set of data, small sample size, which is n less than 30, and another set of data, large sample size, which is n greater than 30. Okay, small n greater than 30. So why we divide our sample in that way? Because we need to see the difference, okay, what happened when we have small sample and also when we have large sample. Okay, so means that the histogram data you should have 4 lah in your report. Okay, so 4 set of data, then it should be 4 histograms. Okay, so as I mentioned, how you are going to plot this histogram. Okay, you must use the Microsoft Excel. Okay, there is no manual plotting, okay, for your report. Okay, so there is after you construct the histogram, you need to comment on your histogram or interpret the histogram. So in that question, what we need, the first one is a shape, the shape of the distribution, okay, based on the histogram. Okay, okay, so you have 4, so here we have 8 common pattern for the histogram. Okay, you will get either bell shape or it is a symmetric actually. Okay, a uniform, J shape, reverse J, right skewed, left skewed, bimodal, and U shape. Okay, so try based on your data, based on your histogram, try to find the closest pattern that you can based on this 8 common pattern. Okay, because when we have a real data, your real data could be hilarious. Okay, could be diverse punya data. Okay, so we will have variation of the data lah. So you have many kind of data. You could have the outlier. Okay, so outlier is if you go through our notes for this week, okay, outlier is a extremely high or extremely low data value which is isolate from the rest of the data. Okay, let's say that most of your data is from 50 to the 250. So the outlier is out of that range, maybe 1,000 or 8,000. So it could be the outlier. So when you have this kind of layer, then you might not this kind of the data. So you might not get similar shape as what we have here in book. Okay, so you can, it is not improvised. So what we do, we try to find the closest pattern that we have, okay, to this common shape. Okay, so for example, and also you can write like this. For example, that for the bimodal here, okay, based on your data, okay, for the bimodal, it should get exactly, let's say that U shape lah. Okay, let's say that So the U shape here, the first bar and the second bar here should be the largest one. Okay, they could be the highest one, or maybe there is a difference between them. Okay, so let's say that we have this one. Okay, let's say that your data, when you plot, the second bar here we have this, similar as the first bar. And this one quite higher here, for example. Okay. Okay. So it looks like U shape, but it is not really U shape, for example, like this. Kat sini pun sama, like this. Okay. Looks like U shape, but not really U shape. So what you can write here, we can write approximately U shape, for example. Okay, approximately U shape. Okay, and the histogram here, how we determine the pattern here, it is based on our eyes, how we visualize that one. Okay, how we see those patterns. Okay, based on the visualization. Okay, when we discuss mean medium mode, okay, that one is another way to determine the shape. Then it could be, we can confirm using that lah. Okay, histogram is more to visualization, how we see that pattern lah. Okay. Question so far?
No, doctor.
No, madam.
Okay. So this week should be start from 1.2.5. Okay. So the step 5 here is just presenting and analyzing the data. So one of the method that we can use to analyze is a descriptive statistic here. Okay. The simplest one lah. Okay, how to analyze the data, we go to the descriptive statistic. We calculate the mean, based on the mean, what we can discuss about the data, based on the variability, what we can discuss about the data, okay? Or we go to the inferential statistic, okay? So your part B of your assignment, it is about inferential statistic lah, hypothesis testing, okay? So here just a theory information that you have to know. Okay, you can read by your own. Okay, all this method that you can use to analyze your data. Okay, and then the last step of the statistical methodology here is a decision and conclusion. Doesn't matter how big is your research or how small is your research, your report must be wrapped or must be closed with the conclusion or decision to your problem. A good report, you wrap together and then close with the conclusion or decision to solve the problem. Okay. Okay. So we go to the review of the descriptive statistic. Okay, so just what we call summary of the topic for this week. Okay. Okay, so descriptive statistic, one of the method that we can use to analyze the data, a simple one, okay, a simple value that we can calculate to analyze our data, and then we interpret our data based on that value lah. Okay, so we have 3 measures for the descriptive statistic. We have measure of central tendency. Okay, so measure on the central tendency here, it is about the middle of your data set. Okay, the middle of your data set. And then we have measure of variation. So measure of variation, measure that we use to discuss the variability of the data set. So what is variability? Okay, variability is terms that we use to discuss the consistency of your data. How separate is your data? Okay, so we use measure of variation. Or if you have data, what we call, how close your data to each other. Okay, also using variation. Or how close your data to the mean, okay, central of the data. So we use also variation. Okay, and then we have the measure of position. So measure of position, position here is to measure what we call. So measure of position give us the information, the position of your data set. So we have quantile, we have decile, we have percentile. Okay, but we use a lot quantile in this chapter, or in this course we use a lot the quantile. Okay, and percentile we use a lot in education to discuss the position of student based on score, for example. Okay. Okay. Rule of thumb, okay, everybody should know that this one, okay, please take note, every value that you calculate for this course, it must be at least 4 decimal places. Okay, when we deal with the data, it will be a lot of the decimal places lah, okay, of our value. So I need you to use at least 4 decimal places. Okay, at least 4 decimal places. But sometimes we have to use a whole number. That is okay lah. If your variable it is the data should be the whole number, then you can round up lah to the whole number. Okay, if not, if that value it can be in continuous value, then I need at least 4 decimal places. Okay, and also unit, if the unit stated, then you have to give unit of your value. Okay, in your assessment, if you have less than 4 decimal places and there is no unit, I will deduct your mark. Quizzes, test and final, similar. Okay, so you have to take note. Okay, so you should practice with the calculator. I believe that everybody got their own calculator. Okay, doesn't matter what we call here, the brand that you have. Okay, if you are not using these two, then you can always Google how to do it. Okay, so for the first exercise, for the practice, you can use the manual calculation. You can do the manual calculation for the mean and variance letter. But when we go, especially when we go to the chapter 2 onwards, we don't expect you to calculate manually. Okay, it just wastes your time lah. If we go manual calculation means that you use the formula to calculate the mean, to calculate the variance, because we will use a lot mean and variance later. Okay, so what we need you to do, use your calculator, key in the data, and then get the value that you want. Okay, so by using calculator, we can get calculator will give you 2 value, but based on that we can get the variance also. Okay, so in your calculator we can get these 3 value. Okay, x bar is a mean, so doesn't matter the data that you key in is a population or sample, we will use similar mean because similar formula for the both. Population mean and sample mean, there are we have similar formula. So in calculator we use similar value lah. Okay, the second value here, okay, this is population standard deviation. Okay, population standard deviation. So if you need variance, you just square the value given. Okay, the third one, sample standard deviation. Okay, so why we have 2 different value for the standard deviation? One for the population, another one for the sample, because calculator cannot distinguish lah whether the data that you key in is a population or sample. So you have to decide which value that you will need to use, population or sample. Calculator will give you both, but you have to decide, okay, whether you want to use a standard population or you want to use the sample value. Okay, based on the data that we key in. So how to know the whole story lah? Okay, whether the data is a population data or sample data. Okay, so you should practice with your calculator when we go to the quizzes, when we go to the task and final. Okay, don't calculate manually. Okay, you just waste your time. Use your calculator. Okay. Okay, so measure of central tendency. Okay, it is about, or we call it as a measure of average. So it is about middle of your data set. Okay, we have mean, median, mode, and mid-range. Mid-range is a simplest measure that we use for the to measure the central of the data. Okay, So the mean median mode here, it can be used to describe the shape of the distribution. Okay. So now we have two methods that we use in order to get shape of the data distribution. The first one, we use the histogram, and the second one, we use the measure of central tendency. Okay, so in your quizzes or tests, be careful when you read your question. Okay, the shape that you need to determine based on what? Whether based on histogram or based on the measure of central tendency. Okay, or if they don't mention, then it's up to you lah. You can use either one. Okay. Okay, so mid-range, just a rough estimate. Okay, so this is how we calculate the mid-range. Okay, largest value plus the lowest value and divide by 2. Okay, and then we have mean. Okay, so here we have similar formula for the mean. Okay, both is about summation of data divided by number of data. Okay, so what is the difference? Your notation. Okay, so how do we notify reader? Okay, whether the value that we have here is a population or sample, it is by using notation. Okay, you have to state the value here is a mu or S bar. Okay, because similar formula, you will end up with the similar value lah. Okay, so how do we distinguish? Is based on the notation used. Okay, that's why I said build the known with the notation. If the value that we calculate here, we got notation, then write the notation so that will be used with the notation. Okay. Okay. Then we have the median here. So this is the formula how we calculate the median. So median, it is about position of the data. Okay, we try to identify the median number of n ordered data. So position of the data. What number at the middle? Okay, so that's why you have to order the data smallest to the largest because it is about position. So similar when we go to the measure of variation, it is about position of the data. Then we have to order the data smallest to largest. Okay, so we have formula odd and even here. When n is an odd number and when n is an even number. Okay, just a simple formula. Okay, but if you have another method how to calculate for the median, you can use that one. This one is just official one. Okay, so for example here we have 5 data, so order first your data smallest to the largest. Okay, so 5 data and is an odd, then use this one. 5 plus 1, 6 divided by 2, 3. So add 3. So data number 3 in order. It is not 3 is your answer. So data number 3 in order, which is 5. Okay. And then the second one here, we have n equal to 6. So we have even. So means that 6 divided by 2, 3. So data number 3 plus the next data number 4 divided by 2. So data number 3 plus data number 4 and then divide by 2. So you get 6. Okay. Just a simple formula here. But don't forget to order the data. Most of students, they forget to order the data. Okay, formula shouldn't be a problem. Okay. So mode, the most commonly occurring value in a data series. So we use mode a lot when we have qualitative data. Okay. So mode is not always unique. Sometimes there is no mode in your data. Sometimes we have one mode. Sometimes we have more than one mode in your data. Okay. Okay. So based on the mean median mode, we can determine the shape of our data distribution. Okay, that's why I said this is a second method that we use to determine the shape. The first one by histogram. Okay. The second one by measure of central tendency. So measure of central tendency here, it is for the mean, median, and mode. So how do we determine the shape? Okay, so this is the common pattern that we have. Okay, so we have what we call this different from the histogram here. By histogram, we can have about 8 shape, but by using measure of central tendency, we only have 3 shapes. Okay, you will have either symmetric, right skewed, or left skewed. Okay, so this is the common one. Okay, if your mean, the value of mean similar to the value of median, similar to the value of mode, then you will have symmetric. Okay, if the mean here greater than median, greater than mode, then you will have right skewed. Okay, and the last one here, if the mean less than median and less than mode, you will have left skewed. Okay, this is the common one. Okay, but as I said, when you have a real data, you might not get this one. Okay, this I mean the common pattern here. So what we can do to determine the shape, you can plot. Okay, you can plot and then determine what shape that you have. Okay, as you know, for example, there is no mode in our data. So what to do? Okay, what shape that we can use? Okay. Okay, so you can memorize this one or you can try to plot. Okay, let's say that we plot those. Okay. Okay. So what we plot only on x-axis here. Okay. So the x-axis here, it is based on the value of mean. Okay, value of mean, median, and mode. Okay, the value of. Okay, the y-axis here, it fits already. Okay, y-axis fits. So the value, the x-axis, it will be changed. Okay, based on the value of mean, median, mode. So we plot based on the value of mean, median, mode. Okay, so how for the y-axis? Okay, so when you have mean, okay, fits here means that the highest of your bar. Okay, the height, sorry, the height of your bar. Okay, so mean here always be the lowest bar. Okay, median bar or moderate bar, which is higher than mean, and mode, it is the highest bar. Okay, so this one cannot be changed. It is fixed already. Okay, it is fixed. Okay, but for the value of mean, median, it will be changes here. Okay, so you can plot here. Okay, for example, that there is no mode in our data. Okay, let's say that our mean equal to 16, our median 70, and mode not exist. Okay, so you can plot. Okay, you can plot. So we know that mean is the lowest one. Okay, so 16, 17. So here mean, lowest bar. Okay, and then median, moderate one, which is higher than mean. So higher than mean. And there is no mode. You can add another bar here just to see what pattern that we have. And then we will have what shape here? What shape that we have here?
Skewed to the right.
Skewed to the right. Skewed to the right?
Skewed to the left.
Skewed to the left.
Negative school.
Negatively skewed or left skewed. Okay, or negatively skewed. Okay, so if you want to memorize, then memorize. If you want to sketch, then sketch. But my personal one, personal opinion, I think you should know how to sketch, and then it will be easy to identify what shape that we have. Okay, especially when we have real data lah. Okay, because we can get any kind of data. Okay. Okay, this is an example. Okay, properties of the mean and median. Okay. The most important one here, mean is affected by extremely high and low value. So extremely high, low value here, it is the outlier. Okay, we call it as outlier. And then median here is affected less than mean by the outlier. Also affected but less than mean. So means that mean is more affected by the outlier than the median. Okay, let's see how it is affected. Okay, I'll show here. Okay, so let's say that we have simple example. Oh, sorry. Oh. Okay. So I want you to calculate, let's say that we have sample, S bar, the mean, and median. So let's call it as a median one. And then what happens if we add extremely high number, which is like say 100. Okay, 100 here. So calculate the second mean based on when we add the 100. So S bar 2, and then I need the median 2. Do it now. I give you 2 minutes. And then I need the answer. Okay, you can write the answer in chat or you just tell me lah. Done? Anyone? Anyone? For the S bar 1 and S bar 2? The answer? Okay, so mean one is a 6.6. Okay, so please take part and everyone when I said calculate this and calculate. Okay, because in class I can what we call I can check or I can see one by one, okay, whether you do it or not. But online it is on you. So try to participate, okay, with the class, okay, and then inshallah you will be more understand what we are doing now, what we are discussing now. Okay. Okay, so thank you for the answer. Okay. Okay, so so now we suspect that when I add this 100, okay, we suspect that it is an outlier lah, okay. So when we go to the 1.4, it will be some calculation that we do to determine whether it is a really outlier or not. So now it just suspect to be the outlier, okay. So let's calculate the difference. So difference of mean S bar 1 and also S bar 2. Okay, so we have 22.67 minus 6. So we have about 15.667 difference. Okay, so difference of the median 1 and also median 2, it is only 0.5. Okay, so when there is a difference between the old value here and the new value here, it shows that the 100 here affected the mean and also the median. Okay, both are affected, but mean here is more affected than the median because the difference here higher than the difference for the median. Okay, difference of X bar greater than difference of the median. Okay, that's why the mean here is more affected than the median. Both are affected, but mean is the worst one because it is more affected, okay, than the median because of the difference of the mean higher than difference of the median. Okay, that's what we mean by the mean is more affected to the outlier than the median. Okay, hope that you get it, that one. Any question so far? Okay, so that's why because of this, okay, that's why it is related to the exercise that we are going to discuss after this. Okay, that's why okay, when we have the symmetric, so this is a symmetric data, okay, or you have the skewed data. Okay, doesn't matter that you have right skewed or left skewed, both are skewed data. Okay, this is a skewed data. Okay, when we have symmetric data, most of the data value, it is in the range of data. Okay, let's see here. So most of the data value will be between these. The probability that we having outlier is low for the symmetric data, or maybe there is no outlier at all. Okay, so that's why when we have symmetric data, it is best to use mean as a measure of central tendency. Okay, because symmetric, the probability that we have outlier is low, or maybe there's no outlier at all. Okay, so the best measure to use for the average is a mean, because mean, it will be affected when we have the outlier. Okay, so it is best to use when there is no outlier exists. Okay, but for the skewed data, we might have the outlier at the tail of your distribution here. Okay, so the tail of the distribution here could be consist of the outlier. Okay, so the best measure to use for the skewed data, doesn't matter right skewed or left skewed, it is a median for both. Okay, because median less affected by outlier, it is affected but less affected by the outlier. That's why when we have skewed data, median is the best to use, not the mean. Okay. Question so far?
No, madam.
No, Doctor.
No, madam.
Okay, we go to the exercise 1.3.1. Okay. So find the mean, median, mode, and mid-range. That one I leave it to you. Okay, just a simple calculation here. Okay, so we go to the interpretation. Okay. Is the average value calculated in A, parameter, or statistic? So you have X bar or mu here for the mean here.
It is a statistic.
Statistic, which is X bar. Why statistic?
Because it stated the number of hospitals.
Again?
It stated that the number of hospitals
That's it.
selected for
Selected countries. Okay, because here it states here selected countries. Means that the data here only collected from selected countries. So it is sample. If you have like for all countries, then it is a population. So that's why here we have S bar. Okay. What is the number of variable here? Number of variable. What is not number of variable? What is your variable here? What kind of data that we take here? No, variable. What is the variable?
number of hospitals.
hospital.
Number of hospital. This is your variable. Okay. Variable denoted by X. Usually we use capital X to represent variable. Okay. Variable is very important when we go to the chapter 2, 3 later. So it is best for you if you know how to identify the variable starting from chapter 1. Okay. What is the distribution type that describe the data? Okay, so because of we calculate mean, median, mode, you will have
Right skewed distribution.
right skewed. So right skewed because here we have mode less than median and less than mean. So if we sketch, you will get mean the lowest value, so mean first, and then median, moderate, and then we have mode the largest value, so mode here. So that's why we have right skewed. Okay. So what is the best measure of average of this set of data and why?
It is median because it is less affected by the outlier.
Okay. It is median, but it is not the reason. Okay, we cannot say that median because it is less affected by the outlier. No, that's the properties. Okay, why here we use median? Because it is not always we use the median. We can use the mean. Okay, so why here? And also if we said that median is less affected by the outlier, it is not right because we don't identify or we don't try to identify any outlier here. And we don't know whether the outliers exist or not in the data. If it is confirmed that we do have the outlier, then we can accept that reason lah. If you say why median, because median is less affected, okay, by outlier. Okay, but here that's not the correct reason. What is the reason here? Why it is median? Median is correct, but reason is not.
Maybe because of the distribution, the right skewed distribution.
Because we have skewed data.
Okay.
Why median? Because the data is skewed. Okay, so the reason why we use median here because we have skewed data. Okay, do not try to discuss the outlier here because we don't even try to identify the outlier. Okay, any question?
No, doctor.
Okay, so we go to the variation. Okay, so measure of variation, or we call it as a dispersion. Okay, similar thing lah, dispersion, similar thing. Okay, so we use this measure to determine the spread of the data value. How spread is your data, which is related to how consistent is your data. Okay, and those things represented by verbality lah, the term that we use to represent all that thing is a verbality. Okay, so we discuss probability to know how spread of our data, how consistent of our data. Okay, so we have 4 measures here that we discuss under this subtopic. So we have range, we have variance, and standard deviation. Okay, so these 3 measures we use when we compare similar variable. Okay, so similar variable means that similar unit. Okay, let's say that data 1 kg and data 2 also kg. So similar unit, similar variable, then you can use either one, whether range, whether variance, whether standard deviation, either one. Okay, but coefficient of variation, we use CVR here, CVR, okay, to compare different unit of data. Okay, let's say that here we have kg and here we have cm. So we have 2 different variable, 2 different unit. So the only value that we can calculate to compare durability is a CVR, coefficient of variation. So definitely you cannot use the range, you cannot use the variance, and you cannot use the standard deviation. Okay, it is wrong to use all these 3 when we have different variable. Okay, so CVR only for the different variable when we want to compare different variable. Okay, kalau you ada single data, okay, doesn't matter what unit it is, we just need to interpret single data, then you can use either one from this 4 range, variance, standard deviation, or coefficient of variation. But when we try to compare between data set, let's say that we have 4 data set, 3 data set, 5 data set, you have to look at your unit. If similar unit, then you can use either 3, 1, 2, 3. If different unit, then the only one is a coefficient of variation. Okay. Okay, so measure of variation may help researchers to describe data more accurately, because by using variation, we can know how consistent our data. Okay, because sometimes it will be not significant to use the measure of central tendency, for example, mean. Okay, in some cases, okay, mean is not significant to use, so we go to the variation to describe the data, to compare the data, to know whether we have a good data or not. Okay, so variance and standard deviation are used quite often in inferential statistics. Okay, I think I have mentioned before this when we go to the chapter 2 onwards. Okay, because again, chapter 1 here is about theory behind the applied statistic, what you need to know, what you need to understand, the terms that we use. Okay, so but here all this will be using in chapter 2 onwards. Okay, so variance and standard deviation we use a lot, especially in chapter 2 and 3. Okay, in fact, based on this, we determine which formula that we need to use. Okay, okay. Before I forget, we have quiz 1 next week. Okay, I forget to mention to another section, but it's okay lah to inform you now, or inform another section. So next week, it will be quiz 1. Okay, it is about 1.2 and 1.3. Okay, it will be on Wednesday like today lah. Okay, it will be on Wednesday. I'm still not sure whether we have quiz first and then we discuss the exercise, or maybe I still don't decide on that, but I think we start with the quiz first. Okay, so what about half an hour for the quiz? Okay, through the Google Classroom, and then you submit in Google Classroom. Okay, I will share the question on that day lah. Okay, 1.2 and 1.3. Okay, these two subtopic. Okay, so during the quiz, you have to on your camera so that I can see you when you answer that quiz. Okay, so half an hour on your camera, do the quiz, and then you can off, and then we continue with the class. Okay, iklan kejap. Okay, we go to the range. So range here is just a what we call the simple measures for the measure of centrality, measures of variation. Okay, easily affected by the outlier, one extremely high and low value. So easily affected by outlier. Why? Why do you think range affected by the outlier? Why?
Because the range needs the highest value or the lowest value, and the outlier is one of the value.
Yes, because range in this formula itself, we need the highest value and the lowest value. So your outlier could be the highest value or the lowest value, or maybe both are outliers. Okay, so that's why range is easily affected to you, easily affected by the outlier. Okay, that's good. Okay, and then we go to the variance and standard deviation. So standard deviation just a square root of the variance. Okay, so this is why in your calculator, it provide you with the two value, population and also sample, because of different formula. Okay, as you can see here, the difference is on the numerator. Okay, so we population divide by number of data, and sample divided by number of data minus 1. That's why we have different value for the population and sample. Okay, so variance is the average of the squares of the distance each value is from the mean. Okay, when we have more than one data set, okay, usually how we interpret the variance, we tend to compare, okay, the probability between those data sets. Okay, but when we have single data, okay, single data set, okay, how to interpret, it is about average of square of the distance each value is from the mean. That's how we interpret the variance when we have single data. Single data set, not the single data is one. Okay, when we have single data set, so how we interpret the variance, it is about average of square of the distance each value from the mean. Okay, but when we have more than one data set, then we go to the comparing the variance between those data sets, and then we try to compare which one is a better data, which data is more consistent, okay, and so on. Okay. Okay, so standard deviation just a square root of the variance. Okay, so pay attention on the notation here. Okay, it is very important. So S, and here is a sigma. Okay, and then we have properties of the variance and standard deviation. So variance and standard deviation always positive value. There is no negative value. Okay, there's no unique for the variance. Okay, whenever we calculate variance, it is a dimensionless. There is no unique. But for the standard deviation, we do have unique lah. So unique for the standard deviation, it will be follow the unique of your data. Okay, so if your data in kg, then your sigma or S will be in kg also lah. Okay, so follow your data. Okay, if the data values are near the mean, the variance will be smaller. If the data values are far from the mean, the variance will be larger, because the variance itself, it is about the distance. Okay, the distance of the data value to the average. Okay, if we sketch these 2 points, okay, you will have this one. Okay, here. Okay. This is the mean, mu or S bar. Okay, the red one means that your graph shrink. So means that your data value here close to each other, close to the mean. So we have smaller variance. Okay, but the what we call the black one here, okay, we have larger value, larger variance. Okay, larger variance. Okay, because of the value, the data value far from the mean. Okay, if we try to illustrate. Okay. Okay, and then we have coefficient of variation. Okay, so it is about standard deviation divided by the mean. Okay, as I mentioned, we use when we try to compare different variable. Okay, different variable means that we have different unit. Okay, so population and sample, we have similar similar formula. Okay, so it is standard deviation divided by mean and multiply with 100 lah, because it must be expressed in terms of percentage. Okay, but how do we interpret similar as range, similar as standard deviation, similar as variance? The smaller it is, the better the data it is. Okay. Okay, this one. How do we compare the range, the variance, standard deviation, the CVR, and another one in a measure of measure of position, we do have quantile. So based on quantile also, we can measure the variation. Okay, that one we call it as a IQR, interquantile range. Okay, interquantile range, it is about Q3, third quantile minus first quantile. Okay, also we use to measure the variation. Okay, so it doesn't matter what value that we have here, how we interpret similar. Okay, the smaller the value, the better it is. The smaller the value means that your data will be less dispersed, less spread, less variable, more consistent, more precise, more accurate, and better data. Okay, larger value, then you will get opposite to the smaller one. Okay, so this is the terms that we use when we discuss the variability. So try be well known with the term here, because in your assessment letter, it could be one of this one. Okay, so you have to be well known, you have to be used with the terms that we use here when we discuss the variability. Okay, the smaller the variability, the better the data it is. Okay, so why we need measure of variation? So to judge how well the data it is lah, and also to judge how well the measure of average illustrate the data. Okay, so as I said, sometimes measure of central tendency do not give any significant meaning. For example, Okay, we have this group of data. Okay, so the data is about score of the task. So both group we have 6 data. Okay, when we calculate the mean, both mean is equal to 66.67. So X bar for the A, so we have similar mean for the both data, means that mean is not significant to use. Okay, to discuss how well the data it is, to discuss which data is better one. Okay, so that's why we go to the variability or variation. Okay, okay. By illustration, we can see that group A is more spread. Okay, if you can see here, the distance between the data here is larger than group B. So we can say here, group B is more consistent than group A. Okay, so to confirm that, you have to calculate any value that related to the variability. Okay, so we go to the simple one, which is range. So range of the data A, it is 90 minus 60. Sorry, 90 minus 30. So you get 16. Okay, so range of the B, $85, $50, so 35. Okay, so based on the range here, we can write range of A greater than range of B. So means that group B is more consistent. Okay, because range of A greater than B means that B less than A, then B is more consistent. The smaller the value, the consistent it is. Okay, the more consistent is the data. Okay, so mean cannot be used because similar. So we cannot compare. Okay, which one is a better one based on the mean. So that's why we go to the variation. Any questions so far?
No,
No,
madam.
madam.
Okay, so we go to the exercise 1.3.2. Okay, so which of the following set of sample data is less variable? Okay, so the keyword here, less variable. So how to identify which one is the less variable? Okay, so in order to know which one is the less variable, then that's why we go to the variability. Okay, so here you have to understand why here we calculate for the variability, because of we have keyword less variable. We cannot calculate mean to discuss the variables. Okay, we cannot calculate median, we cannot calculate the measure of central tendency. Okay, so related to the less variable is a probability. Okay, so that why you have to understand why here we calculate variability. Okay, so variability, what kind of value that we can calculate? So both is about method. So it is similar variable. So you can calculate the range, you can calculate sample data, S square, or you can calculate the S. Okay, either one, similar variable, so either one from this string. Okay, because here it is about variability. We try to identify which data is less variable. Okay, you cannot just because of this exercise under this subtopic, then you just jump to the variability. Tak boleh Okay, you have to really understand why here we calculate variability, why here we discuss variability. Okay, because when we go to the assessment letter, it is a mix of subtopic. So we didn't mention, you didn't know which subtopic it is. Okay, so that's why you have to understand why here we calculate variability. Okay. So you can calculate either one, range S square or S. Okay, so use your calculator here. Practice to use your calculator, key in the data and then get your S. Here is a sample data, means that we use the third value, which is a sample standard deviation. Okay, if you need S square, then you just square that value. Okay, so here we have SA 3.6742 and SB 7.8493. Okay, that's the value. And then we go to answering the question, because the question is not what is the value. It is about which one is less valuable. Okay, so the next step is to compare. So we have SA less than SB. So which one is less valuable?
Method A.
A.
SA.
Method A. So method A is less valuable. Which one is better one? A or B?
A.
A, because A is less valuable. Sekejap ya. Sekarang tu boleh. Okay, the second question. The following set of sample data represent the battery lifetime for two different brands. Which brand of the battery is performed better? What is the variable here?
Battery lifetime.
The battery lifetime. Okay, so battery lifetime in hour. That's your variable. Okay, so we have two brands. Which brand of battery is performed better? So we need to know which one is a better one, which one is a good one. Okay, so what we can calculate here, or what measure that we can use here? The keyword is perform better. What measure we can use here? What we can discuss here to know which one is a perform better? It is
Variability.
variability. Okay, it is variability. Aku sayang cakap, well, it's a variability. Okay. So, variability. Can we calculate CV out here? Can we calculate CV out? Coefficient of variation?
Can.
Can or not?
Yes.
Yes. Sure.
Cannot because it is same variable.
Cannot because it is same variable. Okay, both is okay. Both data we have hour as a unit. So we cannot use CVR because similar unit. So you can choose either one from three with the range S and S square. Okay. So other than variability, okay, this question, okay, it is a general question. Okay, general question because it just mention or it just asks about which one is performed better. Okay, so general question. It is not like the first question, less variable, more consistent, and so on. Okay, okay, so it just perform better. Okay, the first measure that we can calculate is variability. What is another measure that we can calculate here to discuss this, to know which one is a perform better? Another measure that we can use.
Range.
Median.
Okay. So range is a one of the variability. So under variability, another measure that we can use other than variability. What is another value that we can calculate here other than variability value? Median. Okay. So it is a measure of central tendency. Okay. So usually for the when we try to compare the data set by using measure of central tendency, we go to the mean, not the median, we go to the mean. Okay. So another measure that you can calculate here is a mean. Okay. How the mean should be in order to know which brand is perform better. The mean should be larger or smaller?
Larger.
Larger. Why larger?
Lifetime.
Because of lifetime. That's good. Because of lifetime. Because of the variable. Okay. Okay. So we know that for the variability, it must be smaller. Okay. But for the mean, it must be larger. So first, the keyword is perform better. And the second one, because of the lifetime here, the variable also contribute to that. Okay, because battery will perform better if they have longer lifetime. That's why mean should be greater. Okay, so here doesn't matter what value that you use, mean or variability, you should conclude similar thing. Which one is the best one? Okay, which one is perform better? Okay, so why variable here contribute to the mean? Okay, okay, because when we change the variable, let's say that we change the variable. The simplest one is a number of defective. Let's say that this is about production. Okay, we collect the data about the number of defective from, let's say, 10 production line, for example. Okay, what happened to the mean here?
Yes, use about the map here.
What happened to the mean here? How the mean should be in order to know which one perform better? If we have this kind of variable, the mean should be
Smaller.
smaller because it is about number of defective item. Okay, so that production line should be perform better if the number of defective item smaller or reduce or decrease. So the mean here, the mean that we need should be smaller. Okay, so variable influence how the value should be in order to know which battery is perform better. Okay, any question? So I leave it to you, the comparison you can do by your own based on what we discussed for the number one. Okay, so here brand B should be the better one. Okay. Okay, so we have accuracy and precision here by using concept of variability. Accuracy means that how close a measured value to the true measurement. So means that how close your data value to the mean. So we just discussed that we can use variance to determine that. Okay, how close the data value to the mean. Okay, so precision here, how close the measured value to each other, or how consistent means that how close the data value to each other. Also we use the probability. Okay, so this is a game of that to illustrate the accuracy and precision. Okay, so just a quick exercise here. Okay, try to identify whether we have accurate or precise or both. Okay, so here the A, accurate or precise?
Precise.
Precise. B, accurate or precise? So this is precise. B should be, it is
Accurate and precise.
accurate but not precise. Why? Because 18 and 22 here quite far from each other. So just accurate. Okay, why accurate? Because here we have average 20 with the error. Okay, so accurate lah. Most of the value, it is within the error. So accurate. C,
Good.
Precise. Not accurate.
not accurate because 20 here, the true measurement is 20 and this is our measured value. So just precise. D,
Precise.
precise only,
Not accurate.
not accurate. It is far from the true measurement. The E,
Both.
both. Right, really. Okay, the average of the 5 trial 35 and the true measurement also 35. Okay, so accurate. But we don't know the measured value here. So it could be not precise. So not precise lah here. Okay, just accurate. Okay, so similar to what we have discussed in for the group A and group B just now. Similar mean, but the position is different. So it could be not precise because we don't have the measured value. So it just accurate. Okay. Okay, so we go to the measure of position. So position here to give information to us about the position of your data. Okay, so when it is about position, means that automatically you have to order the data. Okay, smallest to the largest because it is about position of data. Okay, so we have 3 measures here. Okay, we have percentile, we have decile, and we have quantile. So percentile, we split the data into 100 equal parts. Okay, and decile, we split the data into 10 equal parts. Okay, and quantile into 4 equal parts. Okay, we use a lot percentile for the education punya research because based on percentile, we can know the position of the student. Also, if we're talking about we can discuss the performance of the staff, performance of the student based on the percentile. Okay, we don't use design a lot, but we use quantile a lot. Okay, as I mentioned before, based on quantile, we can also measure the variation in the data set. Okay, and also we will use in a box plot later the quantile in 1.4. Okay, so we measure also variation based on quantile. Okay. So we have similar formula here. The difference is your denominator. So I here represent, so the I here represent which part that you want. Let's say that for the percentile, you want like 75, P75. Okay, so I equal to 75. Okay, n number of data and then divide by 100 because 100 equal parts. So similar to the decile, similar to the quantile. So the difference is your denominator. Okay. Okay, so we have, okay, so what we have here, the at C here, it is position of the data in your data set, in ordered data set. Okay, and we have formula for the C. Okay, let's say that C here we get decimal places, continuous value. For example, that we have x 5.5. Okay, so what we call the formula is we need to round up to the next whole number, which is at 6. We do not use the common rounding what we call rules. Okay, even though you have like 5.001, also we round up to the next whole number, which is at 6. Okay, so means that data number 6 in order. That's your answer lah. Okay, if we have continuous value or decimal places. Okay, let's say that we have whole number. Okay, let's say that at C here at 5. So what we need to do, we add with the next whole number, which is at 6, and then divide by 2, and then you get your answer. So data number 5 plus data number 6 divide by 2. Then you get what is your decile, what is your quantile, what is your percentile. Okay. That's the formula that we use. Okay. So why we need measure of position? We discuss in exercise, which is okay. Okay, exercise. This one. Okay. So one of the reason why we have quantile here, it is a rough measure of the variability. So we can use interquantile range to discuss variability in a data set. So it is about Q3 minus Q1. So how do we interpret similar as? Range similar as S, similar as S square, similar as CVR. Okay, the smaller it is, the better the data. Okay, the smaller it is, the more consistent of your data set. Okay. Okay, we go to the exercise. Okay, so given a set of data, so we have this set of data, find the value correspond to the fault decile. So you have to order the data. Okay, so just a simple one here. So D4, and then we need the third quantile, Q3. Okay, use the formula. Okay, we go to the number 2 here. So it is about score of student. Okay. Okay, let's order the data first. 3, 7. I miss one value. 3, 7. Oh, 9. Okay, 9. Okay. Okay, so this is education punya area line, education. So what we can discuss here. Find the score correspond to the 20 percentile. So we need P20. Okay, so based on this answer, you can do by your own. It is equal to the 8. So 8 somewhere here. 8. Okay, so means that your P20 somewhere here. So what we can say, the 8 student here, okay, the student that got 9 until 22 here, we can say that they score better than 20% of student in class. Okay, we can say here these 8 students, they are in top 80%. And these 2 students, they are in bottom 20%. Okay, the interpretation that we can write about percentile. Okay, because we use a lot to discuss the performance of student. Okay. I think the rest just a simple calculation. Okay, any questions so far? Any question? Okay, ada eh? Okay. Okay. So just now we discussed the best measure of average or the best measure of central tendency. Okay, so what about the best measure for the variation when we have symmetric data and also when we have skewed data? Okay, so similar here, symmetric, and you have skewed data. Okay, so it will be similar characteristic. Okay, so when you have symmetric data, okay, as we know for the measure of central tendency, mean is the best one because of the probability that we have outlier is smaller. Okay, when it is a symmetric. Okay, when we have skewed, okay, so the best one will be median. Okay, for the measure of central tendency, for the measure of variation, okay, so it will be either, okay, variance, standard deviation, CVR, okay, versus IQR, interquantile range. Okay, so range, it is just a simple measures. Okay, okay, we go to, this is not complicated one, this is range is a simple one, but when we calculate for the variance, standard deviation, CVR, okay, it is more accurate. Okay, so these three, it will be the best to use when we have symmetric data, and IQR, it will be the best to use when we have skewed data. Okay, but when we have the same variable, then we go to these two lah. Okay, if we try to compare the same variable for the data set, then we go to these two. Okay, CVR only for the different data set. Okay, so this one best to use when we have symmetric, and IQR best to use when we have skewed data. Why? Why do you think? Why variance best to use when we have symmetric? Why IQR best to use when we have skewed data? Kenapa? Why? Tak apalah, saya jawab lah. Because of variance, standard deviation, and CVR consist of or involve mean in the formula. Okay, because we consider mean in the formula of variance, in the formula of standard deviation, and also in the formula of CVR. Okay, so that's why it is best to use for the symmetric. Okay, so variance, standard deviation, CVR, it will be affected more when we have the outlier because of the mean here. When mean affected, automatically variance, standard deviation, CVR also more affected by the outlier. Okay, and IQR here, similar reason to the median. It is about position of the data, which is less affected for the when we have the outlier. That's why when we have skewed data, it is best to use the IQR. Okay, that's the conclusion. Any question for today? Okay.
No, madam.
Okay. So
No, madam.
Okay, that's good.
No, madam.
Okay. Apa nak cakap tadi? Okay, I think I'm not miss anything, but if you go through the tutorial question, if anything, you can always text me lah. Okay, for the first response, please text me within the office hour. After the office hour, if you text me after, at night, I will what we call, we review first your message whether it is important or not. If not, I will just reply the next day lah. Okay, so similar to the weekend, try not to text me during the weekend and also after the office hour. Okay, but if it is really important, then you are free to do that lah. Okay, any question you can ask me, you can text me. So if you still if you don't have the module, then you can always redo the exercise first, and then if you have the module, then you can go through the tutorial question. So as I said, next week will be the quiz one. Okay, it is a 1.2 and also 1.3, only that two lah. Okay, that two subtopic. That's all for today. Thank you for your cooperation. InsyaAllah, I will see you next week. Thank you.
Thank you,
Thank you,
madam.
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay. How about? Okay, attendance. No need to worry about attendance. I think I will start the attendance next week, and then I will be backdated lah. Okay, starting from week 1 until week 3, and then you can just fill out that form. Okay, thank you.